to use it, I will on it and use. Okay, the meeting is being live streamed. All right. Now, this is what I want to show. Just check whether you can see this. Okay. Can you see a ball?
Yes.
To use it, I will on it and use. Right. So some things I will show over here. Some things I will show over there. Now, this is what I want to show. Just check whether you can see this. Okay, 6 done. Can you see a ball?
Yes.
To use it, I will on it and use. Right. So some things I will show over here.
Yes, ma'am, you are quite visible and other backgrounds are also clear. So I think it is all good.
Your good name, ma'am?
What, ma'am?
Oh, your good name?
Varsha.
Varsha. Okay. Nice, Varsha. Thank you very much. Okay. I guess everything is fine.
Yeah. Professor Pushpa Bindal ma'am is on her way. So today she left late from the college and there's a huge traffic. So she will be joining us in like 10 minutes.
Okay.
And there's some emergency with Professor Punita. So I don't know whether she will be able to join us today or not. But Professor Bindal will join us in 10 minutes.
Right. Perfect.
Yeah.
And the students will be joining.
Yes, ma'am. So students are greeting you. Good evening, ma'am.
Good evening. Good evening.
So meanwhile, I just share the poster screen so that we can know about our webinar
Programs. Yeah. Thank you. Thank you.
Yeah. Ma'am, so today in the demonstration you are showing, so these are from like which topic?
This is based on solid angles.
Okay. So you use them in your like classrooms also in like teaching lectures?
Unfortunately, I've started doing this after my retirement. So this particular thing I have never shown in my classroom, but I've shown it in quite a number of teacher programs, students in webinars.
So now it's not limited to just to the classroom,
That's
but to
true.
the entire
That's
India
true.
and maybe abroad also.
Yeah, that's right. Actually, the webinars have become an open platform for everybody to join.
Yes. And since it is streamed on YouTube also, so outside India also students
will be seeing. Yeah, that's
channel.
That's courtesy Nasi. Thank you very much.
Thank you, Nasi.
Thank you. Yeah. I want the children to chat Okay, and I would like to see the chat. Is it possible?
Yes, ma'am. On your screen, there's an option of chat. If you can see, otherwise I'll read. And
You'll read and tell me. Okay, bye. Thank you. Because I want the students to interact with me. Now they unmuting and talking will become a chaotic.
Yes.
So I thought if they can chat, I will be replying
Yes.
based on, I would like to question, they give their answers. I'll see the chat and I will know what the answers are.
Yes, ma'am.
Okay.
Yes, I will read all the chats.
All right.
चलो चलो आ गई, पहुंच गई किसी तरह।
Hello, ma'am.
हाँ हेलो। शर्मिष्ठा मैम ने भी ज्वाइन किया हुआ है ना?
Yes,
Yeah.
ma'am. She
Hello, ma'am.
joined
Hello.
before the participants.
शर्मिष्ठा मैम सॉरी, मैं बिल्कुल ट्रैफिक में फंस गई थी, पूरा
No.
था। आई
Uh, Thank you so much for coming with all that. You'll have college in the morning and you're taking time off. Coming from the college, it's really tough.
एक्चुअली आई डोंट नो व्हाई
Hello, ma'am.
हाँ हेलो। पूरा 1.25 घंटे से भी ज्यादा लगे पहुंचने में।
Anyway,
It is so nice to see you. Although I have met you online in online meeting with Professor Verma.
I'm not able to hear your voice properly. Is there some problem with your audio or?
Yes, ma'am. I was just about to say, Pushpa, ma'am.
Uh,
Your audio is very weak. Maybe you can
ठीक है।
the device near
एक
to you.
सेकंड,
Yeah.
लेट मी चेक। शायद
Yeah.
एक सेकंड। अरे पूरा नहीं दिखा रहा।
If you have earphones, maybe, ma'am, you can connect them.
अच्छा ठीक है, वो पूरा नहीं दिखा रहा, नहीं तो वो दिखाता है ना। एक सेकंड रुको, मैं ईयरफोन्स यूज करती
Because a slight echo and is there. I don't know.
हूँ। मैं देखती हूँ, ईयरफोन से ट्राई करती हूँ। Is it better?
yeah,
Yes.
much better. Yeah.
Okay. So nice to see you in person.
Yeah, you were telling something. I didn't get it actually.
Actually, I said कि I have seen you online with Professor, in Professor Verma's meeting.
Acha, okay. Yes.
Yeah.
Right.
Many times.
We were doing the nest together.
Yeah.
Right. Now they are getting ready for the semi-finals, which will happen from 5th.
Yeah.
Supan Ashram.
You are all contributing to such a noble cause, I must say. I mean, putting in so much of time and energy and, figuring out all this, thinking of all such basic experiments. I mean, it involves a lot of physics, and how to do it. That is the main thing.
Yeah, no, it's all Professor Verma's guidance.
But still, he needs a good team to put it into practice. And you certainly, contribute largely to that.
That's true.
Yeah.
So, ma'am, I think we can start. It's already time.
Yeah, we can.
Yeah.
ये एक बारी वर्षा उस पे शेयर वगैरह कर दिए वो जो ग्रुप था वेबिनार।
Yes, ma'am, already did.
ठीक, okay, so we can start formally.
Yes.
So good evening everyone. So today, as I said, we are very fortunate to have Sharmishta ma'am here. She is a very profound physicist and she has been working along with the legendary Professor S.C. Verma and contributing to, the academic community, particularly young students, igniting their minds, forcing them to think out of box. It is really a noble cause. And, lots of people are trying to contribute a bit to it. We are also amongst that. But still, their contribution is certainly, too much. Very large, on a very, very large scale, they are, contributing to this cause. So today we are fortunate to have Professor Sharmishta Sahu here. So she is going to enlighten us on solid angles all around and easy estimate. It sounds so interesting and so intriguing. Professor Sahu is a retired associate professor of physics at Maharani Lakshmi Amanani College, Bangalore. She is a coordinator of IAPT Anveshika, wing of NANI, Indian Association of Physics Teachers, Bangalore. She did her post-graduation from Utkal University. She works as a volunteer for Indian Association of Physics Teachers, Indian Science Academics, Bangalore, and the Autonomous Agastya International Foundation. She has been awarded 2 national awards, One of them is National Competition of Innovative Experiments. She has got it 6 times. And the second is the National Competition of Innovative Computational Physics, and she has got it thrice. She has authored 2 books on understanding physics, 8 volumes, and concise physics, 8 volumes again. So she has conducted innumerable workshops. She has worked in the Women's Development Center for 5 years. She has many publications in national and international journals. Her interest is in conducting workshops, demonstrations, lecture series, and developing science models. She did 3 UGC minor research projects. She excels in many computer skills like MS Word, Excel, and PowerPoint presentations. So welcome, ma'am. We are looking forward to your talk, and we are all, looking forward to being enlightened by your expertise. So please, over
Thank
to
you
Samisha,
very,
ma'am.
very much. Thanks a lot, ma'am. It's a really wonderful platform to talk to children, and I'm grateful to you, grateful to Nasi, grateful to Kalindi College and all the department teachers over there who are conducting webinars after webinars, and all for the sake of children. Fantastic work. Keep it up. I'm excited that I'm again coming to your college for one of the other seminars, which is today. So I will talk to the children. As you have already mentioned the topic, I don't have to tell them. But my only request would be to the participants, whoever is here, I don't like to talk alone. Okay, I want my whole class to be talking one after another. There should be a group discussion. There should be interaction from all of you so that it is a two-way process. Of course, since it is a webinar, I'm not able to see you. I cannot really appreciate your expressions, your excitement and enthusiasm. It's a pity. So what we will do is, since talking may not be feasible because you need to unmute, talk, and the time is very short, if it is possible for you, instead of unmuting, if you can put it in the chat box, and I would request once it is there in the chat box, we can interact through writing. But wherever possible, if you can unmute and talk, I would also request you to please talk. Now, when you are unmuting, please take care that nobody else is unmuting at the same time. In case you find somebody talking, then you kindly give her the space and time so that she finishes whatever she has to say, and then you can talk. So I would request all the participants to actively participate in this. It has to be a wholehearted, active participation. This program, I call it as an activity-based learning. So I want to do some activities, and both of us are learners, all of us are learners. So we will learn from that activity. Am I clear? Yes, I want you to reply. Am I clear?
Yes, ma'am.
All right.
Yes, ma'am.
Okay. So I'm all ready for that. How I will do is this. I will show you a demonstration, and based on the demonstration, I will be asking you questions, and whatever you answer, we will proceed from there. Therefore, your answering is very, very important, because otherwise, if you don't answer, we have a halt over there. Okay, so if you want things to be progressing, please do answer. Okay, my first question is, all of us are sitting in rooms. Probably it is a cuboidal room. You have walls and you have a ceiling. Look up at the corner of your room. There is a corner which is having 2 walls and a ceiling. Look at that corner, please. Are you seeing any corners like this? There are 2 walls and a ceiling forming a corner. Yes. I want some of you to please tell me, what do you think is the solid angle at that corner? Watch physics all around you. So please see and then tell me. Yes, I want an answer. Either you unmute and tell, or you put it in your chat box.
Jainder Kumar Sinha has written pi.
Somebody has written pi. Okay. Pi what? In physics, if you take something, it has to have a unit. Okay. So pi what? Jayendra sir? Pi star radians. Okay, so sir has one suggestion. It is pi star radians. I'm not saying yes or no. Anybody else would like to try? What do you think is the solid angle over there? Somebody quickly. Vinu sir, yes?
Ma'am, kindly repeat the question, please.
I said, what is the angle at the corner of your room where the corner is made by two walls and the ceiling? Please look up at the corner and then you make an estimate and tell me what is the solid angle there. Somebody is saying 180 degrees.
Yes.
Sorry, this is
Not
not in degrees.
2
Cannot
pi
be in
multiplied
degrees.
by 1 minus cos alpha.
Pardon?
2 pi multiplied by 1 minus cos alpha.
2 pi multiplied by
In
1
bracket,
minus
1 minus
cos alpha. What is that alpha, sir?
Alpha 90, then 2 pi. 2 pi
No,
stay radian maybe.
You said, acha, you are saying 2 pi star radians. Okay, so I have one more answer. Somebody said pi star radians. Somebody else is saying 2 pi star radians. I still want one more answer. Yes, please. Somebody has answered 180 degrees, 1180 degrees. Please note, degrees is a measure of planar angles. Is it a planar angle? No, it is not in one plane. It is having spatial distribution, and therefore we should not be talking in terms of degrees. I guess you have understood that. So now can anybody make another guess?
Muhammad Ali has written pi by 2.
Pi by 2 what? Again he says pi by 2 question mark. Okay, so there are different answers. Pi by 2, 2 pi. So different people have different guesses. Now let's look at this. I want to use this to make you understand what is a solid angle and how we can determine. What is this? Anybody? What is this?
A brinjal?
It's a brinjal. Yes, I want to cut the brinjal, that stem over there, to make it a circle. So now I have made a circular brinjal. Okay, brinjals are all around us. Can we study solid angle with a brinjal? Let's try. Okay, now the brinjal is a sphere. Can you see that? It is a sphere, and therefore it should have a center at the sphere. Do all of you agree? Yes. And therefore, suppose I say this sphere has a radius r. Well, let that be anything, I don't care. It should be r. Then what should be the surface area of this sphere? If the radius of the sphere is equivalent to r, what should be the surface area of the sphere? Yes?
4 pi r square.
Excellent, Shakshi ma'am. Very good. Keep it up. It is 4 pi r square. So how do we define solid angle? Let me tell you. The surface area divided by the square of the radius will give you the solid angle. So at the center, the solid angle is equivalent to this whole thing. Correct? This whole thing has a surface area equivalent to 4 pi r squared. And I said the radius of this sphere is equivalent to r. Solid angle of this whole thing should be equivalent to 4 pi r squared divided by r squared. So how much is it?
4 pi.
4 pi star radians. Please note, solid angles are measured in a unit called star radians. And every time without fail, we must write the corresponding unit. Because if we call it as degrees, then definitely it will not be correct. So the total solid angle at the center of this sphere is equivalent to 4 pi star radians. Look at that number, 4 pi star radians. Does it depend upon the radius? No. So the total solid angle about a point at the center is equivalent to 4 pi star radians. No matter what be the shape, if I take this point over here, then the solid angle around it must be equivalent to 4 pi star radians. Clear? So any point has a total solid angle in all around it in the space, which is equivalent to 4 pi star radians. Now I want to find out how I can find out the solid angle at different points. Okay, So I consider the same point over here. I have cut the sphere into two halves. Okay, the point that I was talking about is over here, right? So what is the solid angle over here alone? Okay, the total solid angle all around about this point was equivalent to 4 pi steradians. You suggested and you told me very beautifully. Now I'm asking you, what should be the surface, the angle between this surface, the green surface at that center?
Mole has written 3 pi. Kanika has written 2 pi steradians.
3 pi, 2 pi. We said, just look at this. The total angle is equivalent to 4 pi steradians. I divide it into 2. And therefore, at the center, the surface over here, the angle over here should be equivalent to about this point, should be equivalent to half of it.
2 pi.
It will be
2 pi. Yeah.
4 pi divided by 2 is equivalent to 2 pi. Very good. Okay. So it is equivalent to 2 pi. Fine. It is 2 pi, but I want you to tell me in a term which is represented by 4 pi. So suppose instead of 2 pi, I call this angle at the center over here equivalent to 4 pi by 2. Will I be wrong? Yes? No, 2 pi is equivalent to 4 pi by 2. 4 divided by 2 is equivalent to 2. And therefore, 2 pi can also be written as 4 pi by 2. Am I clear? Therefore, this point has an angle equivalent to this much, which is equivalent to 4 pi by 2. Clear? Yes? Okay, clear, ma'am. Now I just want to put it with a mirror. Now look at this. I'm holding some few mirrors with me. I want to use a mirror and tell you how reflection is formed with a plane mirror. Do all of us know what a plane mirror is? Every morning we use the plane mirror to comb our hair, dress up, do variety of things. So all of us are aware about a plane mirror. Clear? So what do we do with a plane mirror? It's all around us. Yes, what do we do?
Reflection.
Reflect.
Answer.
Reflect the light.
Yeah, we see images. Fantastic. We see our reflection. We see our face. We are getting a reflected image, or we are seeing images. Fantastic. So I want to see the image of this half a banana on my plane mirror. So when I keep this plane mirror thing, banana over here, the point that I was talking of at the center over here is making an angle equivalent to 4 pi by 2. Is that clear? At that point, it is making a solid angle equivalent to 4 pi by 2. Now look at the image through this plane mirror. Can you see the image? Can you see the image?
No, ma'am.
No. Can I pin? How do I pin? Yeah, let me see if I can do it. Pin. Yeah. Can you see the image now?
Yes, ma'am.
Yeah. How many images are you seeing?
Only one.
Only
One.
one. Can you see that the image of the brinjal and the brinjal itself is looking like the original brinjal?
Yes.
ma'am.
Excepting for the thickness of the mirror, just ignore the thickness. It is looking like a whole brinjal. Am I right? So now the half a brinjal that I put over there was having a solid angle equivalent to 4 pi by 2 steradians. But when I put it on a plane mirror, I am able to see one image, and it looks as if it is a full sphere or the full brinjal. Okay. So with one image, I had one object in front of the mirror. I am seeing one image behind the mirror. Totally, what is the total number of image and object put together? 2. Very good. So there are 2. One object and one image, 2. What was the solid angle at the point over there? This solid angle? 4 pi by 2. Very good. So it was 2 pi or 4 pi by 2. So when the solid angle was equivalent to 4 pi by 2, I got one image plus one object. Perfectly fine. Now I want to cut it into half again. Okay. So I took that half brinjal and I made it into quarter brinjal. Okay, therefore at this point, what is the solid angle by this green surface over here? This is solid angle. How much is it about this point?
5 star radius.
5/4.
It is equivalent to?
5
5.
It is equivalent to 4 pi by 4. I'm insisting that you please talk in terms of 4 pi just for convenience. You will understand why I'm insisting that you should tell in terms of 4 pi. Very soon you will understand. So now, previously the whole thing, half a brinjal at this point had an angle equivalent to 4 pi by 2. And if I cut it into half, it will become half of that. And therefore, the solid angle at this point over here is equivalent to 4 pi by 4. Any doubt? Amreen ma'am is telling 4 pi by 4. Very good. So I want you to tell in terms of 4 pi and you are doing it perfectly fine. So you made a split. You made kept that point constant, but you are decreasing the solid angle. Am I not decreasing the solid angle? It was initially 4 pi. I made it half of that, made it 4 pi by 2. Now I've made it 4 pi by 4. Okay. Now again, let me put it about at this point, I want to enclose it with mirrors. Therefore, I should put a mirror over here. I should put a mirror over here. Then this point will be completely enclosed by the mirror. So I have now putting it between these two. There are two mirrors over here. I'm putting that mirror between the, putting the brinjal piece between the mirrors so that I get images of the brinjal. If you look at the images, can you see? Can you see something? How is the brinjal looking? Is it a quarter of a brinjal?
Yes.
No.
With the images, does it look like a quarter of a brinjal?
No, ma'am.
No, it looks like a full brinjal.
Full
Okay.
brinjal.
Yeah, suppose this is
It's
opaque and
clear.
therefore you cannot see the back of it, but still you can guess that it is looking like a sphere. Got it? Okay. Now, this angle that I put over here, that means this point that I was talking about, this point over here, I'm enclosing it with two mirrors so that the total solid angle over here between the mirrors, solid angle, is equivalent to 4 pi by 4. Any doubt? No. Yes? Hope you've got it. So it is equivalent to 4 pi by 4. The solid angle between any point over here is equivalent to 4 pi by 4. How many images you are seeing? Because it is opaque, you are not able to see the images. So I would prefer to do this so that you can see the images and then decide what I'm asking you to be able to tell. This is my object. Instead of a brinjal, I'm keeping an object over here. Okay. Now please see how many images are you seeing? Three images. Okay. So there are 3 images, including the object. How much is it? 4. 3 images plus 1 object, 4. What was the solid angle of that point between the mirrors?
4 pi.
4 pi by 4. Beautiful. So when the solid angle is equivalent to 4 pi by 4, the number of images plus object, we are getting 4. 3 plus 1, 4. When the solid angle was equivalent to 4 pi by 2, we got 1 object plus 1 image, totally 2. Yes? So I'm sure you can see something, some pattern is developing. Now I will talk about breaking this into still another part. So now this point, which was having a solid angle equivalent to 4 pi by 2, was, I'm dividing it again into half. So now I have the same point over here, enclosing a solid angle, which is this much. Okay, this much. So what is this solid angle over here? This solid angle over here?
4 pi by 8.
4 pi by 8.
Beautiful, beautiful. Half of the previous one. Therefore, it is 4 pi by 8. Excellent. Amreen, Naz, many people are telling. Excellent. So you are now telling me, somebody has already guessed it. Anmol Setia is telling number of image plus number of images. Number of object plus number of images is equivalent to denominator. Beautiful observation. Beautiful observation. Let's see it in a few more cases before we can conclude. Okay. We can, it may not be true. So I'm just trying to do it a couple of times. So now the solid angle over here is equivalent to 4 pi by 8. Many of you have suggested, Muhammad Ali sir, Amreen, Naz, girl, madam, whatever I'm student, whoever you are, I'm very, very happy that you are opening out and you are answering. Keep it up. So the solid angle at this point over here is equivalent to 4 pi by 8. I wish to again keep it between the mirrors. So what will I do? I'll keep a mirror over here. I will keep a mirror over here. I will keep a mirror over here. Then it will be enclosing this point, and that corner will be equivalent to 4 pi by 8, which I'm doing it right away. I'm having three mirrors. I have designed it like that so that I can keep the brinjal, and it will be having a corner equivalent to the corner made at the center of that brinjal, which is equivalent to 4 pi by 8. Now look at the images. Is it a full sphere? Ignore the thickness of the mirror because that is looking as if there is a big split. Okay, can you see now or imagine what is there visible?
Yes, ma'am.
Yes, it is looking like a full sphere. Okay, even though I'm keeping only a quarter of a sphere or 1/8 of a sphere, it is still looking as if it is a full sphere. Okay, the angle at this corner, is equivalent to 4 pi by 8. Now I want you to count the number of images. When I keep this brinjal, it is creating problem because it is opaque, but still you may be able to see. Can you tell me how many images are there? You will have to probably guess. Okay, I will, instead of keeping this brinjal, I will put this rubber over here. Now look at this and tell me how many images are there. Please count and tell. Probably if I keep a colored thing, it will be easier, and a smaller thing. I'm keeping another object, a pink rubber. Please count the number of images and tell me.
4 ऊपर है.
और नीचे
4 होंगी.
दिखाई दे रहा है?
Object. 3 images plus 1 object.
Pardon? हाँ, नीचे भी दिखाई दे रहा है?
4
6
images
images plus 1 object.
So 7 images and 1 object.
Beautiful, beautiful. There are 7 images plus 1 object. There was somebody suggesting 6. If you look at it carefully, you will realize this is my object. I'm shaking it. So there are 3 images in this area. Below, if you see, there are 4 more images. Can you see 4 pink things at the bottom?
Yes, ma'am.
Yeah. So there are 4 at the bottom, 3 behind this, totally 7, plus this object itself is equivalent to 8. Therefore, there are 7 images plus 1 object. Binu sir is telling, Amreen is telling, so many of you are telling. I'm glad. So now you have got the feel of it. Somebody was suggesting probably the denominator is equivalent to the number of images plus the object, which is equivalent to 1. Here also we are seeing the same thing. The total angle, solid angle, was equivalent to 4 pi by 8. And the number of images that we got was equivalent to 7. Number of object was equivalent to 1. Therefore, the total number of image plus object is equivalent to 7 plus 1. Therefore, the entire space, which is equivalent to 4 pi, is occupied by the images and the object. And the number of images plus the object is equivalent to the denominator of that 4 pi by 8. Now you understand why I was insisting that you should write or tell in terms of 4 pi by 8. So we are seeing it that if the solid angle is 4 pi by 2, we got 2 object plus image. If we were getting the solid angle was equivalent to 4 pi by 4, we got 3 plus 1. When it is equivalent to solid angle is equivalent to 4 pi by 8, we are getting 7 plus 1. You can now very well guess. So suppose the solid angle was equivalent to 4 pi by 14. How many images should you get?
13.
13. Wonderful. Suppose your solid angle was equivalent to 4 pi by 19. How many images would you get?
18.
18. Wonderful. Wonderful. So you've got it. You've got it. Shall we try it once more? Okay. Suppose I feel I will again cut it. I will make it very small. cut it again into half. Now I am going to cut it into half because it is easier for me to cut. But I can cut it into 1/4, I can cut it into 1/3, I can cut it into 2/5, and so on. The calculation will become difficult, therefore I'm doing it half, half, half. So the solid angle at this point over here, this green area is occupying a solid angle. That solid angle should be equivalent to, now everybody should be telling it. How much will that be?
4 pi by 16.
16. So how many images do you expect?
15.
Wonderful. So you expect 4 pi by 16. If the solid angle, you should get 15 images plus one object. Totally it will become equivalent to 16. Beautifully said. So shall I make a little challenge over here? Let me do it. Okay. I don't know. This one, I want to keep it over here. Now, how do I occupy this corner? It has to be flushed. There should be a mirror flushed over here. There should be a mirror flushed over here. There should be a mirror flushed over here, which I have tried to make over here. And I'm keeping that brinjal over here. Can you see that it is a full sphere?
Yes, ma'am. Yes, ma'am.
It is a full sphere. You are seeing it. So every time when you keep the object, the image plus the object is occupying the whole space. That is why it is looking like a full sphere. Yes or no? So you're seeing something very, 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 very interesting. Every time the object and the image put together is becoming a full sphere. That means it is occupying the full space. 4 pi steradians. The number of images I want you to count over here, maybe it will be very, very difficult, but then I'll try with, let me say, my pink. Very difficult for you to count because it's getting stuck. Okay. Now you can see something. You cannot see something else, but I'm sure you should be able to guess. We have seen it previously. Please count the number of images and tell me why it is so. What it is first. Yes, ma'am, it's a crystal clear. It is crystal clear. Very nice, very nice. Thank you. And you made it clear, not me. Tell me how many images are there. Please look at this, count and tell me. I don't want you to tell from air or your guess. I want you to count and tell me.
Penny has written, ma'am, 13 images.
13.
There are 13 images. Beautiful. Many of you are telling. Khushbu Rani, Srinivas Rao sir, many of you. Okay, beautiful, beautiful. So we are now seeing 13 images plus one object, totally 14. Got my point? And I told you that this point over here is having an angle equivalent to 4 pi by 16. Challenge. Is it matching with whatever we were saying previously? Prior to this, before I showed you, I was actually asking you the number of images and you told me very clearly we should be having 15, but now you are counting it as 13. Is our theory wrong or is there something else? Any guesses? Any guesses? Somebody is saying our image is getting superimposed. Wonderful choice. Wonderful choice. It is overlapping. Somebody says, no, it is overlapping. Truly, no, it is not overlapping. Actually, this is my, thing, whatever 1/16 I have done. I had actually done it in wood. I wanted to do things which are around in my home and therefore I brought a brinjal. If I put this point over here, I will get a sphere, but look at this. Is it actually flushed with that point? No, there is a lot of gap. That means this corner over here is actually equivalent to 4 pi by 14. I had asked my carpenter to do an angle which is equivalent to 4 pi by 16. So obviously when I keep this, it is not fitting in properly and you are getting only 14 images. Therefore our theory is perfectly correct. The design of this apparatus is not okay. Probably if I had taken 3 mirrors and kept it like this and like this and like this and showed you, you would have got 16 images. Why? Probably you will. I wish I can show it to you. Yeah, I'm showing you. I've taken 2 mirrors. I'm putting it over here and holding it tightly so that the corner that I form is now equivalent to 4 pi by 16. Now, if you count, you will be able to see that there are how many images? If you can count, can you count?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Very difficult to count. I will put something colored. I will keep this perfectly. Move it carefully. Put this image. Now, if you count, you will be able to see. Please start counting.
1, 2, 3, 4, 5, 6, 7.
7 plus 1 in the top, and there are 7 plus 1 at the bottom. So that totally it should be equivalent to 16, of which 15 are images and 1 is a thing. Very clear? Sorry, I'm saying clear for me because I'm seeing it over and over again. I'm very sorry I'm not able to show you properly, but if you look at it carefully, 1, 2, 3, 4, 5, 6, 7, and the object. 8 of them on the top, can you see? So obviously, each one of them will have a reflection at the bottom, and therefore there should be 8 images at the bottom, 7 on the top. Totally, there are 7 plus 8 is how much? 15. So there are 15 images plus my object, which is that pink rubber. Can you see? So if you make the corner perfectly, then obviously you should get whatever you are telling me now. So if the corner that is made over here between these 2 mirrors, which I shifted, these 2 mirrors and the third mirror over here, this corner, what is the solid angle? If it is equivalent to 4 pi by 16, then I am getting 15 images plus 1 object. Got my point? So now let us say what is the general theory or what is the general formula. Suppose I call this solid angle is equivalent to phi and the number of images is equivalent to n. Listen to my statement carefully. If I call the solid angle as a general term phi radians, the radians, and the number of images is equivalent to n, then what should phi be equivalent to?
4 pi by n plus 1.
Plus 1.
Beautiful. You've done it. You've done it. It will be equivalent to 4 pi by n plus 1, where n is the number of images plus 1 is the object. Okay. So you have now told me the formula. Phi should be equivalent to 4 pi by n plus 1. Who wrote the formula? Is it Newton's formula?
No, ma'am.
Is it Einstein's formula? No,
No.
it is your formula. Who did it? Who told me the equation now? It is you. The spectators over here, the participants over here, the actively participating into the activity and coming to a conclusion saying that it is equivalent to, the solid angle must be equivalent to 4 pi by n plus 1. Got my point? Okay, so now that you have told me the formula, you have understood very clearly that suppose I do not know the solid angle. I went to a museum. Now let me show my face. If I go to a museum and I see some corner over there, which is very beautifully, the architecture is beautiful, and I want to find out what is the solid angle at that corner. Obviously, it's a solid angle. If I'm talking about a corner, it is the spatial angle I'm talking about. How do you think you will find out? Let us say you went to the museum and you had your lipstick mirror and maybe your rose mirror, or you had some sandwiches wrapped in aluminum foil, and I want you to, or you want to find out what is the solid angle. How will you do it? Yes.
By counting the number of images.
Formed on due to the mirror that is kept in the corner or the aluminum foil that you can take, polish it and make it a reflecting surface, put it about the corner, and you will be able to see the number of images. Maybe you can put your finger over there, stick your finger and count the number of fingers you are seeing, and then tell me the thing, solid angle. Very easy, because you just now told me the solid angle should be equivalent to 4 pi by n plus 1. If I get n number of images, I immediately know the solid angle is equal to 4 pi by n plus 1. Beautifully said. So I have already asked you. So suppose I want to find out the solid angle. This is what you will do. Okay, you will put some mirrors about that solid angle, put an object and count the number of images. You know that how it is related, and therefore you are telling me. So you can find the solid angle so very easily. Yes. So suppose I want you to now tell me what is the solid angle at the corner over there. I'm telling you the ceiling and 2 walls. We just now showed you over here. This is your ceiling, this is your wall, this is your wall. This angle I'm asking you. How much is it? Put an object, count the number of images. Tell me how much it is. I hope I'm able to show you properly. Or I can put it like this. Let me say the 2 walls and the floor. And now I put the number of object over there. Count the number of images and tell me what is the solid angle.
4 pi by 8.
Wonderful. 4 pi by 8. So simple. Any corner you get, you can do this and immediately find out the solid angle. Do you know of any apparatus where you can find out the solid angle? Have you seen anything which, with the help of which you can measure a solid angle? Have you seen anything like that? I haven't. In fact, I tried finding in the Google and think what the architects use is something very, very complicated. They do some calculation and find out. There is no device where you can find out a solid angle directly like a planar angle. How do we find out planar angles? You have that device in your geometry box. How do you find out? If I want to measure, how will I find out? Planar angle in a plane.
Protractor.
Pardon?
Protractor.
Protractor. Yes, protractor. So protractor is a device with the help of which I can find out any angle I want. It is in a plane. But I don't have an apparatus with the help of which I can find out a solid angle the way I'm using a protractor to find out the planar angle. But do you have now a device very beautifully suggested by you that yes, I can find out the solid angle? Yes or no? Yes or no? This is your device, multiple reflection. Take some mirrors, put it at the corner, and you will be able to count the number of images. Once you count the number of images, you know the solid angle. Yes. So you are saying yes, yes, yes. I'm not able to hear, and therefore I'm waiting for you to say something. Anyway, now I'm seeing that there are many, many yeses. So now let us do a little exercise and find out the solid angle of all the different corners that I have designed for you to answer. You now know that if the number of images is equivalent to n, then the solid angle is equivalent to 4 pi by n plus 1. Very simple as that. I will show you some corners. I will probably put an object for you to do, keep it, and then you tell me what is the solid angle. If you have understood this, I'm sure you will be able to tell me. I want to show all these images with my mobile. Okay, I have connected my mobile also to the Zoom platform. I will try to use my mobile and then say what it is. Okay, show you what it is, right? So I'm going to my mobile. Please look at my mobile. Okay, can you see? Here I have some mirrors. I have made a corner over here. I want you to tell me what is the solid angle at this corner. So how will you say? It is very difficult to think what. Right. It is very difficult for you to guess like this. So what I do, I keep an object and you look at the object and the image and tell me what the solid angle should be. Yes. Tell me out loud because I can't see the chat box. One of you please unmute and tell.
4 pi by 4.
Excellent. It is 4 pi by 4. I have one object over here and 3 images are around. Now you told me that it is 4 pi by 4 from the formula that you have derived just now all by yourself, and you're telling me it is 4 pi by 4. But I have a doubt. I want to know whether it is correct or not correct. So for that, what I have done, I have made one paper model. Please look at this paper model. It is having 4 surfaces. Can you see the surface? 1, 2, 3, and 4. They are made up of equilateral triangles, 4 surfaces. They are absolutely a solid body. I'm taking out one of these face to show you. Can you see this and this are identical? Do they look identical?
Yes.
If I keep it like this?
Yes, ma'am.
Yes, it is. Okay. So that this solid angle, according to you, since you have counted, should be equivalent to 4 pi by 4. Right? You just now told me that this point over here is having a solid angle equivalent to 4 pi by 4. Therefore, this should be equivalent to 4 pi by 4. I want you to see that whether it is true or not. This face I opened, and this is the exact center of this solid body. Therefore, this is equivalent to 4 pi by 4. Therefore, this surface should have another 4 pi by 4. This surface should have another 4 pi by 4. This surface should also have another 4 pi by 4. Then only it will become a total sphere, and the total, it will be occupying the total space, which will become equivalent to 4 pi. Hence, it is perfectly fine. Can you see that? If this angle is equivalent to 4 pi by 4, then only the total space surrounded by all the object away over here, the solid body over here, at this point must be equivalent to 4 pi. So this has to be equivalent to 4 pi by 4. The point over here should be equivalent to 4 pi by 4. The point over here should be equivalent to 4 pi by 4. The point over here should be equivalent to 4. I'm not showing you, I'm talking. Okay. Therefore, the total should become equivalent to 4 pi. Hence, this 4 pi by 4 is absolutely correct. And your images are also telling you that the point should have a solid angle equivalent to 4 pi by 4. Okay. Let me try doing something else. I have another corner over here. I want you to suggest what should be the solid angle at this corner. Any guesses? What should be the solid angle at this corner? Guess? Difficult. But if you want to make a wild guess, I have no objection. How much do you think should be the solid angle?
4 by
4 pi by
5.
4 pi by 5.
4 pi by 5. Let's check it. Okay, now I'm keeping an object over here. My object is touching all the mirrors. Okay, so that it is going to cover this point. And I want you to count the number of images. Can you count and tell me how many images are there?
4.
5.
5.
What should be the solid angle? Should it be equivalent to 4 pi by 5 or something
4
else?
pi by 6.
It should be 4 pi by 6. Beautifully told. It should be equivalent to 4 pi by 6. You can see 5 images plus 1 object, totally 6. Therefore, this corner must be equivalent to 4 pi by 6. I want you to believe me. If this point is equivalent to 4 pi by 6, how do I prove it? I have done one more object over here. Please look at this. It is a cube. In paper, I have done a cube. A cube, how many faces does it have? Please look at it. How many faces does it have?
6.
6.
I want you to tell because I can't see the chat.
6.
6. I have taken out one cover. Can you see this point? Okay. This angle is exactly same as this angle. Now see both of them together. Are they identical?
Yes.
Yes,
Identical? Yes. Therefore,
Yes, ma'am.
this angle, according to you saw the images and you told it is equivalent to 4 pi by 6. Then the entire space must be equivalent to 4 pi. Let's look at it. It has 6 faces. Each of these 6 faces, if I was opening it out like this, it would make an angle equivalent to 4 pi by 6. So here 4 pi by 6, this 4 pi by 6, this 4 pi by 6, this will be 4 pi by 6, this it will be 4 pi by 6, and this it will be 4 pi by 6. Total about that point, it would become equivalent to 4 pi. Therefore, it is perfectly correct. Therefore, by whatever method you are doing, if I just keep an object and count the number of images, I can immediately tell what is the solid angle. I don't have to verify anymore. I showed you in 2 cases. So I'm sure you are convinced, and I am convinced. Yes, whatever method we are doing is correct, and therefore it is equivalent to 4 pi by 6. Let us look at something else. Again, I have another corner. Okay, I want to keep object, preferably a pen. Okay, can you see how many images are there? Difficult for you to count? I don't know. Can you count? Difficult. Please see. 1, 2, 3, 4.
4 pi by 8.
Pardon? It is actually, sorry, I'm not able to show you because see mirrors, I have to show it 3-dimensional. Can you count now? 1, 2, 3, 4, and top object is 5. Bottom there are, let me count it for you.
Are there 9 images?
1, 2, 3, 4, 5, 6, and 7. There are 7.
Camera.
Totally there are 7. Let me count, put this ball. I think it will be easier for you to see if there is a ball. Can you see now? Count. What should be the solid angle?
4 pi by 7.
4 pi by 7. Did
4
you get
pi by 7.
4 pi by? There are actually 6 images plus 1 object, totally 7. Look at the pink ball. The ball over here is on the top. This is my object, and everything else that you are seeing pink is images. How many images are there? 1, 2, 3, 4, 5, 6. Totally there are 6 images plus 1 object. Totally 7. 6 images plus 1 object. Therefore, the solid angle should be equivalent to how much? At this corner? Yes, I want you to tell aloud.
4 pi by 7.
4 pi by 7. Beautiful. 4 pi by 7. Let me try it out once more. So here I have, this is looking like very difficult for you to count because I'm not able to show a 3-dimensional. It is something is there at the bottom. I can show you only this much. I can't show you. Can you see now what it is? Over here, if I show it like this, can you see it is the edges of a cube?
Yes, ma'am.
Yes, you can. Okay, I have put a pen cap over here to show you the images. It is the edges of a cube. So it is basically looking like something like this. This edge, this edge, this edge, this edge. And therefore, how many edges are there in the cube? If you will look at this and look at this, you will realize. I can show you only this. I am not able to show you. I have to do like this. 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 And still there is one edge over here at the bottom. I can't show you even if I move the mirror, my mobile. But still, can you make it is something look like this? Can you see that? Yes or no? Yes or no?
Yes, ma'am.
Yes. So how many edges are there in a cube? If this is my object, this edge is my object, then how many images should I get? Quickly, quickly. I think you know. How many edges are there in a
11
cube?
images, ma'am.
Pardon?
11.
Beautiful.
12.
Beautiful. So there are 11 edges. Please look over here. 1, 2, 3, and 4. Okay. 5, 6, 7, 8, 9, 10, 11, 12. Because it is formed like this, I've kept the pen and it is formed like this. It is difficult for you to count because I can show you only like this. So you are seeing now 1, 2, 3, 4, 5, 6, 7 edges. You can't see anything else. If I do like this, you will see only a few of the edges. If I do it like this, you will see the other few edges. But you can never see this edge. Okay, there is actually one black image at the bottom, but very difficult for you to show. I can see it. If I bend down, it is a very faint black line, which I can see. So including all the images that are formed over here, it is having only 11 images. Therefore, what should be the solid angle?
4 pi by 12.
4 pi by 12. Wonderful, wonderful. So we've seen so many corners. Each time you have told me, counted the number of images, and you have told me that it should be equivalent to this much, that much, and all the while it was perfect. Now I'm showing you something else. Please look over here. I have a mirror, okay, mirrors with a hole. Okay, there is a square hole over here. I'm keeping that square hole on my board, which is red in color. And what are you seeing? How many images? Can you count and tell me? I'm trying to show you in all directions. What is it looking like?
Sphere.
Pardon? It is looking like actually a hemisphere. Okay, there is a flat surface over here and it is looking like a hemisphere. But how many images are there? Can you count? Just look at this. Are all the images similar? All the while that we were seeing, the images were similar. Are these images similar?
Yes, ma'am.
Not really. It's very difficult for me to show you. Can you see there is a cut over here? There is one triangular image over here, a triangular image over here, which looks as if both the triangular put together is a square, but it is not a thing, perfect square. You can see now how it is moving. Okay. Similarly, if you look behind, below, or in the side, you will realize that these images are not similar. They are all different shapes, excepting a few of them which are squares. Which is a square? The center one is a square. This 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 is not 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 a square. And so also, some of them are squares. Probably the side one is square, but the side one, these corner things are not square. Therefore, it is showing me fractional images. Okay, I'll get back to my place. It is showing me fractional images. You got my point? Suppose you are getting fractional images. They are not full images. Should I be counting the number of images and telling me what the angle is? Because the images are not complete. They are only partial. Okay. Therefore, I will not be able to tell what exactly the solid angle over there is. It is having some complete images and some partial images, probably quarter, 1/3, 1/5, half, and so on. There are many of them forming a hemisphere, but it is not made up of all equal squares, and therefore I cannot tell what is the solid angle. Right? I did not show you that when I was cutting this, I was cutting it pi by 2, pi by 4, pi by 8, pi by 3, pi by 7, like that. But I never cut it into pi by 2.5. Suppose it is equivalent to pi, I'm sorry, 4 pi by 2.5, where one object and 1.5 images are there. Then the angle should be equivalent to 4 pi by 2.5. 1.5 plus 1 is 2.5. Then the image, how will the image be? 2.5 image, 1.5 image. How will the image be? Will they be all identical?
No, ma'am.
There'll be one image full and half an image which is not full, right? So those cases, it is slightly tricky. You will not be able to tell the angle, solid angle perfectly. It could be half, it could be 1/3, it could be 2/5, it could be 1/7, and so on. Therefore, when it is fractional, I was very conveniently avoiding those situations. But at the last, I showed you that yes, if the images can be partial, may not be completely whole. Under such situations, the solid angle, you cannot tell perfectly it is equivalent to this 4 pi by this or that. Not possible. You will only be able to tell it is between this and this. Suppose I had 1.5 images. Then the angle would be equivalent to, please note, if I had 1.5 images, then the total denominator becomes 2.5. The angle would be equivalent to between 4 pi by 2 and 4 pi by 3. I cannot say for sure that it is equivalent to 4 pi by 2.5. It could be 2.5, it could be 2.6, it could be 2.7. It is impossible for me to exactly guess. Therefore, but you can make a very clear estimate saying that it is between this and this. But whenever that the image is a perfect integer, you are very clearly telling me that the solid angle is equivalent to 4 pi by n plus 1 beautifully. And you have done the formula all by yourself. You are the creator of this formula. You have done everything yourself. You did the scientific study. You made a hypothesis. Somebody told me very clearly that the denominator is equivalent to object plus image put together. So you made a hypothesis, you verified it, you saw it in so many cases, and you came out with a beautiful formula saying that this is the formula that I will use everywhere, wherever I want to find out the solid angle. Obviously, because I don't have a device separately by which I can measure solid angle, but I can very clearly do. Suppose I get a fractional image which is not clear, then I can only say it is between this and this, but I cannot say exactly it is this. But whenever there is an image which is countable, 1, 2, 3, 4, 5, 6, 15, 20, 25, 30, then you are clearly telling me that the solid angle must be equivalent to 4 pi by whatever is the counted image plus the object. Beautiful. I'm extremely grateful to you for participating, for explaining to me, for making it clear and actually telling me that this is the formula which probably I never knew. Thank you. Keep it up. Tell me if there is any questions, you want to ask anything, we will do it together. I'm trying to keep my time. I don't want to exceed the time, so therefore I stop. Now you tell me. What is this style of learning?
Raised hand.
Yes, yes.
Any query?
Hello.
Yes, please.
Good evening, ma'am. Ma'am, just I want to confirm that for a solid angle of any device or any shape, can we say that 4 pi upon number of edges? Can we say that?
No, no, no. You will not say number of edges. You will say number of images plus 1. The solid angle will be equivalent to 4 pi by number of images plus 1.
No, ma'am,
If
you have given the example of ma'am, you have given the example of a cube where you have taken a number. Yes, that is why I'm asking.
No. That was a special case. I had designed that corner in such a fashion that it was giving me 12 images. 11 images plus 1 object. Since I had kept 1 pen as my object, which was forming 1 edge, all the other edges were symmetrically distributed to form a cube. Therefore, I told you that it looks like a cube of the edge of a cube, and therefore we know how many edges are there. Why did I tell you that it is looking like an edge of a cube? Because it was looking like an edge of a cube. But I was not able to show you all the 11 images. You understood why I could not show you all the 11 images?
Yes, ma'am.
That is why I was telling, count, since it is looking like a cube, you look at the cube and count the number of images, you'll know exactly how many images there are.
Yes.
Okay, so it's not applicable everywhere. But this is applicable everywhere. Whichever corner you want to find, that corner should have an angle, solid angle, which is equivalent to 4 pi by number of images plus 1. Now, again, my question will be, if the number of images is countable, you will be able to tell me correctly. Suppose the number of images is 7, then you'll know that the solid angle is equivalent to 4 pi by 8. Correct?
Yes.
Suppose it is not countable, as in the case of the hemisphere. That is why I showed you the hemisphere. I don't want to fool you. Okay, so when I showed you the hemisphere, I told you there is 1 square over here, 1 square over here, 1 square over here, 1 square. This is a part of a square. This is a part of a square. This is a part of a square. Now, how do I count? I can't count the number of images. Therefore, I cannot tell you what exactly the solid angle is. But the formula 4 pi by n plus 1 is applicable. If I was able to count, I will tell. If I cannot count, then I can make an estimate. Maybe it is close to 5, therefore, or it is 5 1/4. Therefore, it must be between 4 pi by 5 and 4 pi by 6, because the number of images plus object is equivalent to 5 plus something. It is 5 plus, it is not exactly 6, it is not exactly 5. And therefore, it must be a solid angle between the lower value and the higher value, which is 4 pi by 6 and 4 pi by 5. Got my point?
Yes, ma'am. I got.
Yeah.
Yes, ma'am. I
Okay.
got.
Great.
Thank
Great.
you.
Great. Your good name, please?
Niharika. Niharika Sar.
Very good. Very good. Niharika, you are a BSc student, MSc student.
No, ma'am. Right now, I am a teacher in a school. I
You
have
are a
done
teacher
the
in a
MSc.
school. Beautiful,
I
beautiful,
have done
wonderful question and a wonderful answer from you. I'm extremely grateful.
Thank you,
That
ma'am.
only
Thank you.
shows how enthusiastic you are to know what it is. And you are creating your own knowledge. Now, this
Yes.
type of pedagogy by which you learn, you observe, you see, you understand, and you give the answer yourself is known as constructivism. You are constructing your own knowledge. I am only facilitating. I didn't tell you anything. I didn't tell you that the answer is this or that or this. You did it for me. Yes. Thank you very much. God bless you all.
Like to ask all the participants to please on your videos for group photo.
We can take a picture. Yes, if you have any other questions, I will leave my email ID or any other questions for that matter. If you have and you want to clarify, if I can help, I will definitely help. Sharmista.sahu@gmail.com. You can write a mail to me and I will try to answer if I know the answer, or probably I will try to find out the answer and let you know. Okay, now we'll have a picture. I don't have to pin. I can probably, what do I do? Unpin myself. How do I do it? Remove pin. Yeah. Now we can put together. I want everybody, kindly, if you can,
Please on your videos, yes.
switch on your videos, then we can have a common picture where all of us are participating.
The video is disabled, ma'am.
I will just check. Just give me a minute. I think no, it is on from my side. Please check once again. Yeah, it is now. It's visible.
Can we all have all your faces? Your beautiful faces will be visible.
Thank you, everyone. I'll just take a quick photo. I request everyone, please, on your videos. It will take a smaller time, and all smile so that we can have a beautiful picture.
Thanks a lot. Thank you very, very much. Thank you, Varsha, for all your effort for making it happen. Thank you very, very much.
Thanks a lot.
Thank you, Pushpa ma'am.
Ma'am, we would like to thank you. You have taken all of us on a journey of solid angles, and we have really, come along with you.
Thank
So
you. Thank you.
I think the students, all the participants have really enjoyed your talk, and it was really, very, very informative. We could get, I mean, it was an experiential, learning.
Yes.
True example of experiential learning. So thank you very much. Thank you. And I would also like to thank Nasi for providing the support, Principal Kalindi College for granting us the necessary permissions. And of course, all the participants and Varsha for making it, happen, for making it possible. It was a very, very good session. We all enjoyed it thoroughly. So thank you, ma'am. Thank you very much. We'll be in touch. So any other question? I think kindly the questions are already answered very well. So I think we can call it a day, Varsha.
Yes, ma'am. I think Anmol and Gurtaji has some questions. You can mail to ma'am. Ma'am has shared her email in the chat. So I think you can take from there, or I can at the end read it out for you. So please lower your hand. Sahu@gmail.com. I will just write it again so that you can ask your queries from ma'am.
The attendance come feedback link was also posted in chat box. Please fill it up, all the participants.
Yes, it is shared on YouTube as well as here on the Zoom platform. So kindly fill it. So you want to say something? Hello, sir.
Yeah.
Yeah, Professor
I-
Naushad is
Sir,
here.
nice
I want to have a
meeting
comment
you
here
here.
that for the first time I have listened this about the solid angle, and I want to congratulate Mrs. Sarmishta Sahu that very nicely she has put the concept of the solid angle. Though I have met her in many of the IAPT meetings, but for the first time I understood that she can put so many models and so many labor in this clarifying the concept of solid angle. So it's very nice. I want to congratulate her that she has put very nicely the concept of the solid angle. Thank you very much, Sarmishta.
Indeed.
Thank you. Sir, I met you at Kangri.
Yeah, you came here also.
Yeah.
And
Nice
in
seeing
some
you
also
here.
in Ahmedabad and probably in Kanpur and
Yeah.
we are in Shimla and
Yes.
so many places I have
I
met
had
you.
met you, but I had not realized that you were there. When I saw you in Kangri, I put you in place. Now I know who you are, and every
Right,
time I
right.
see, I
So
get
that
back
was
my
in
flashback.
2017 when we organized here. So you
Yes.
came here also.
Yes.
That was nice to meet you.
And it,
But this you have put a lot of labor in making this all models and showing practically how to calculate the solid angle. That's very nice. I was very impressed with this.
Thank you, sir. Thank you very, very much.
Yeah.
No, it really makes the children enthusiastic, the teachers enthusiastic to know, and therefore it is a good way to learn.
And
Thank
one
you
never
so
forgets. One never forgets.
never forgets. Yes. True, true.
Yeah. Thank you so
I told last time also that we have also put many experiments in our labs so that the people, the students understand the things coming out of from the boxes. And inside the box, they are nothing. They are not knowing anything. And the way of procedure is such a simple in the box that even the fifth class students, they switch on and take the reading, but they will not understand anything. So we have put many experiments out of the boxes, and so that the students can understand what is happening inside. So last time I told, they were saying that we will also make some video and put in on the.
Yes, sir. We are waiting to see them. Hopefully,
Right.
sometimes we will be able to see.
Yeah. Looking forward to it.
That's the way to make the students understand what is happening there. So, okay.
This session, it is a really great and wonderful session. We all got to understand about the solid angles around us.
Yeah.
Thank you so much, Samishta ma'am. It is really a nice, intrigue lecture, as mentioned by ma'am. The topic is itself is like common name is there, but it is a new concept for me at least. So thank you so much for adding it to my knowledge, and thank you the participant who make this lecture so encouraging and discussion. Like ma'am said, it's a two-way interaction. So thank you everyone. Have a good night.